Hello there, everyone, and welcome to this weekly presentation of Morrison Planetarium's Tour of the Universe. I'm Bing Kwok, Assistant Director of Morrison Planetarium, where we are coming to you live and direct from the California Academy of Sciences in San Francisco, California. Now, up until last week, this show was a simulcast of a live presentation that was streamed directly from the Planetarium Theater with a full audience. But for the next couple of months, the show in the planetarium will cover a different topic. However, Tour of the Universe has been so popular for us that it will continue as an online presentation every Wednesday at 4:30 p.m. Pacific on Facebook and YouTube. And as always, if you have any questions, feel free to drop them in the comments and we'll try to respond or maybe give you some links as to where you might be able to find the answer. Our vehicle for this trip through the visible universe is an astronomy visualization program called OpenSpace, which is supported by NASA and which is available as a free download from openspaceproject.com. Openspaceproject.com. If you like what you see on your screen, you can install this very same program on your own computer at home and fly through the universe. The download link will list the hardware requirements for optimum performance. Again, openspaceproject.com. We'll also have a link to a survey where you can tell us what you think of the software, and the developers can use that feedback to improve the program. OpenSpaceProject.com. So, with that, let's take off on a trip to outer space. Actually, we're already in outer space. We're beginning with a view of the International Space Station, which is orbiting about 250 miles or 400 kilometers above the Earth. And, one a famous astronomer back in back a number of years ago, in 1979, said outer space is not remote at all. It's only an hour's drive if your car could go straight upwards. That was Sir Fred Hoyle, a British astronomer, and that's because the internationally recognized boundary of outer space is 100 kilometers, or about 62 miles above the Earth. Originally, it was calculated to be about 50 miles high or 80 kilometers, and for some purposes, that's what NASA uses. It turns out, though, that there really isn't a hard and fast number that you can put on the edge of space because that may vary depending on the expansion or contraction of Earth's atmosphere, and there's no sign hovering up in the sky that says, "Welcome to outer space." So, why is this particular altitude considered to be the boundary? Well, basically, it's where the atmosphere is so thin that air control surfaces like wings and flaps and rudders don't work. Up here, you need rockets to maneuver. So, 100 kilometers above the Earth, the view is pretty nice, but four times higher than that, up here at about 400 kilometers or 250 miles, where the International Space Station orbits, the view is spectacular. The atmosphere is thin enough so that there's not as much atmospheric drag as there would be down at 100 kilometers. And this is where we've got our home away from home, the International Space Station. Although this is as far as most space travelers get from Earth today, there are plans to go about 1,000 times farther than the space station, the way humans did about 50 years ago. And that's to the moon, across a distance of 250,000 miles or 240,000 miles. So let's back away from Earth. And as we do, the International Space Station fades into the distance. It doesn't look like the Earth is moving, but it is very slowly. We're starting to move away from Earth right now. And pretty soon, we'll see the entire planet in our field of view, our beautiful blue marble of a planet. And to help us find the moon, I'm going to add in the orbit of the moon. Let's see if I can find it here. And if we can do that and back away just enough, we'll see where the moon is as it orbits around our planet. So it's right up there. I'll focus on the moon, targeting our destination, and we'll move up to it. Back in the late 1960s and early 70s, it took the astronauts of the Apollo program about 3 days to get from Earth to the moon. We don't have that luxury today, so it'll take us only a few seconds to cross that distance. Not quite at the speed of light, but almost. And what I'll also do is light up the entire moon so that we can see its surface. Let's see if we can. There we go. There's the surface of our moon. I have actually got the moon upside down right now, but you can see the moon is covered with thousands and thousands of craters. Some people ask, how many craters are there? It depends on the size. There are 100,000 that have been identified of a certain size, and then when you get down to smaller and smaller craters, it's a lot more than that. The moon also has, aside from those cratered surfaces called the highlands, that's very old surface on the moon. It has those big dark patches called maria. Now that's a Latin word which means seas, and that's because early astronomers thought that the bodies of water, that the dark patches were bodies of water. They called them seas and oceans and named them things like the Sea of Tranquility, the Sea of Serenity, the Sea of Fertility. But they're not seas at all. They're not bodies of water. They're huge flat plains of dried lava that bubbled up from underground about 3 or 4 billion years ago, covered over the heavily cratered highlands around them, and then cool and hardened into these large, flat, dry plains of rock. And those are the Maria on the surface of the moon. Subsequent to that, in the past billion or so years, there have been later impacts on the surface of the moon, and you can see the craters that were blasted out by those impacts. And that's what craters are. They are the results of the impacts of asteroids, comets, and meteoroids, which exploded on impact with the moon's surface and left behind these large pits, many of which are dozens of miles across. There are several which are, this one here is several tens of miles across. So this flat cratered, flat floored one, another one several tens of miles across. There's a nice big crater just at the end of the lunar Apennine Mountains, which is this chain right here. This crater is called Copernicus. That's about 60 miles across right there. However, right above that, just north of Copernicus, is a very large impact feature, which is known as the Sea of Rains, Mare Imbrium. And Mare Imbrium, you can see, has a round shape. It's circular. And that is because this is a big impact feature on the surface of the moon. The lunar Apennine Mountains are just one edge of the rim of this impact feature. And this whole feature measures about 800 miles across. So the moon is a place with a number of really interesting, fascinating features that. Are interesting to look at. When I was a kid and got my first telescope, I could look at the moon all night just looking at the different features there. Now, the moon is the farthest that humans have traveled from Earth. NASA is testing out its new Artemis spacecraft that will reproduce that effort a few years from now, taking humans back to the moon to explore places that the Apollo astronauts couldn't go 50 years ago, such as the lunar South Pole. Incidentally, all of the Apollo landing sites have been photographed by satellites orbiting the moon, some from distances of only about 30 miles or so, showing the descent stage of the lunar modules and other equipment that they left behind, even the footpaths of the astronauts on the surface. So you can look for those. Earlier, though, I said the speed of light is very important to astronomers. I talked about that. It's the fastest speed in nature. The speed of light is 186,000 miles per second. And at that speed, you could travel 7 times around the world in 1 second. Radio waves, which travel at the speed of light, take 1.5 seconds to get to the moon. And the speed of light offers us a different yardstick with which to measure the universe. As we'll find out, and as Douglas Adams has said, space is big, really big. Trying to express how big it is using miles would be like trying to measure the distance from San Francisco to London in inches or even in millimeters. And so we need to use a different yardstick, and that is the speed of light. So the astronomers express distances in terms of how long it takes the fastest thing in nature to cross them. The distance from the Earth to the moon is 1.5 light seconds. The distance from Earth to the sun at the very center of our solar system is 8.5 light minutes. So from Earth to the star at the very center of our solar system is 8.5 light minutes. From Earth to the orbit of Mars takes about 20 minutes. So from Earth to Mars at the closest distance between the two planets, 20 light minutes. To the orbit of Jupiter, the next planet out, about 45 minutes. And so from Earth, the third planet from the sun, all the way out to the orbit of Jupiter, the fifth planet, about 45 minutes at the speed of light. All the way out to the orbit of the most distant planet, Neptune, 3.8 billion miles away, is about 4 light hours. So the solar system is a huge place, and the distance that the light has to travel gets bigger and bigger the farther out we go. The farther back from Earth, the farther out from Earth we look, the farther back in time we're looking, because the light we see when we look at these objects right now took time to travel to us. So we're seeing the moon as it was 1.5 seconds ago, the sun as it was 8.5 minutes ago, Jupiter 45 minutes ago, and Neptune 4 hours ago. And as we continue out, leaving our solar system behind, we'll encounter objects that are so far that their light takes years to reach us. Now, before we get that far out, let's look at the most distant spacecraft that have traveled from Earth. They've been traveling in some cases for nearly half a century. These are the spacecraft called Pioneer 10, which is the one going off by itself down toward the lower right. And then the other spacecraft are Pioneer 11, Pioneer 11 going in the other direction, way out to the left. And then two other spacecraft, Voyagers 1 and Voyager 2. Voyager 1 is the long path at the top, and then Voyager 2 is the one that takes a downward turn at Neptune. And then there's also New Horizons, which is the one that recently went out toward Pluto, past Pluto just a few years ago. Now, these spacecraft are the farthest that objects that have traveled from Earth. Even the most distant one, which is Voyager 1, has only traveled about 14, almost 15 billion miles, which is not even the distance that light travels in one day. It's about 22 light hours away. And so, again, the farthest spacecraft from Earth is still not that far away compared to the distances of the stars. We're going to see stars that are light years away. So again, the universe is big. As we travel out between the stars, we'll turn off those spacecraft and travel out. And as we travel into interstellar space, leaving the sun far behind, we'll be traveling among the stars. As we do, since we're traveling between the stars, our point of view changes, and familiar looking constellations lose their shape as we find ourselves out where no one has gone before. The most distant artifact that humanity has sent out into space is not a physical object, not a spacecraft, but rather is our radio signals. They've been expanding into space since 1920, unintentionally announcing our presence in the universe. But those early signals are probably too weak to be detected by any possible extraterrestrial species. The first intentional radio signal to be beamed into space was sent back in 1974, aimed at a target about 25,000 light years away, which is even farther out beyond this radiosphere, as it's called. And if there's anyone there, they still won't receive that signal for another 25,000 years. And then on top of that, it'll be another 25,000 years for their reply, if any, to get here. And that's only if they decide to answer. So even though radio signals travel at the speed of light, they haven't gone that far into the galaxy. And this is only our first scratching of the surface in our exploration of the universe. This expanding bubble of radio noise, though, is humanity's signature among the stars. It's us saying hello to the rest of the universe. And as we travel farther from home, we're hundreds and now thousands of light years from Earth. And as we back away far enough, we'll be able to see where we are in the Milky Way galaxy. The Milky Way is a typical spiral galaxy, a barred spiral actually, containing several 100 billion stars and measuring about 100,000 light years across. As a comparison, if our solar system were the size of a coin, say a quarter, about an inch across, the Milky Way galaxy would be about the size of the United States, roughly 2,500 miles across. The next nearest star, Proxima Centauri, and to be generous, any system of planets orbiting around it would be another quarter, located about 2 football fields away. So that gives you a sense of the scale of our solar system and our galaxy. And we're nowhere near the center of the galaxy, as you can see. We, marked by the radiosphere right here, are about two-thirds of the way out from the center. So along the edge of one of the spiral arms. About 100 years ago, astronomers thought there was only one galaxy in the entire universe. And then Edwin Hubble, after whom the Hubble Space Telescope is named, showed that Not only are there other galaxies far outside our own, but they're moving away from us. The universe is expanding. And by measuring the motions and speeds of the galaxies, astronomers say the galaxies have been spreading apart for about 13.8 billion years. Now, the Milky Way is just one member of a cluster of several dozen galaxies called the local group. That includes another large spiral called the Andromeda Galaxy, which is located about 2.5 million light years away. That means that its light took 2.5 million years to reach us. The light we see when we look at that galaxy in tonight's sky has been traveling for the past 2.5 million years, and we're seeing what the Andromeda Galaxy looked like 2.5 million years ago. If you want to know what the Andromeda Galaxy looks like now in 2022, you have to be patient because the light leaving it right now won't get here for another 2.5 million years. But now that we're outside the Milky Way, please take note every spot of light you see on your screen is not a star, but a galaxy, each one containing perhaps a few 100 billion stars. Now, how many galaxies are there in the entire universe? We don't know. But a conservative estimate would be about 100 billion. A more generous estimate suggests there may be as many as 2 trillion galaxies. And we can see that galaxies are clustered together, forming big clumps or chains. There are what are called superclusters of galaxies, gravitationally tied together. Everything you see here is based on real data, based on actual surveys of galaxies taken over the years. And the colors that you see are not the true colors of the galaxies. They represent the particular surveys that the data come from. So we don't have purple galaxies and green galaxies and orange galaxies, but these are the different surveys that have been taken over the years to tell us what populations the galaxies belong to. And this is our current model of the universe based on all those surveys. Look at its shape. What does that tell us? Well, it tells us that the job of surveying the universe is not complete. We're far from done. Does the universe really look like a big bow tie? Well, no, the empty spaces we see in this model are places that we haven't been able to map out very well. And the big empty space between the big cones flaring out to the sides is not really empty space. It's just places where the data are still missing. It's blocked by the dust and gas along the plane of our own Milky Way. As time passes and as our technology develops, we'll be able to see better into these areas and fill out the map more uniformly in all directions. But right now, this is what our model of the universe looks like. The most distant objects that astronomers have seen are called quasars. They are represented by the orange dots you see appearing at the ends of those cones of galaxies. These are also known as quasi-stellar radio sources, and these are powerful sources of radio noise that are extremely far away at a distance of around 10 billion light years. Now, for these objects to be so bright from such an enormous distance, they have to be extremely energetic, and astronomers believe that quasars are the cores of newborn galaxies powered by supermassive black holes, mysterious phenomena that we're only beginning to understand. And surrounding everything, coming from all directions, is a uniform hiss, a pale microwave glow called the cosmic microwave background. This is a faint radiation that's believed to be the lingering echo of the time when the universe began to expand. It was predicted back in 1948 and not discovered until 1964, but it's evidence of the first time that light was able to travel through space only about less than 400,000 years after the universe suddenly changed from something very hot, very dense, and very opaque to something very cool, very rarefied, and very transparent. So, this is the first light that was able to travel from one place in the universe to another. And this is as far as astronomers have seen into the universe. And as we return back to where we started, a really mind boggling fact is that what we have seen amounts to only a tiny part of the entire universe. We've looked to the edge of the visible universe, but astronomers say there's more to the universe than what we can see. By measuring the speed and motions of the galaxies, astronomers calculate that a certain amount of mass is needed to cause the kind of gravitational interactions that they can see. But what they can see doesn't account for the mass that's needed. And so, this is the mystery of dark matter and dark energy, which suggests that what we can see is only about 4% of what the universe is made of. There's a lot more to the cosmos than what our telescopes have been able to detect. And as we return back inward from our trip approaching the Milky Way galaxy, naturally, we wonder whether there might be other worlds among the stars and galaxies that we've seen. And since 1994, astronomers have discovered more than 5,000 other planets orbiting distant stars. These are called extrasolar planets or exoplanets for short. And we see them represented as small circles radiating out from the radiosphere. I'll turn off the radiosphere and we can get a better look at our map of the distribution of known extrasolar planets. And you can see there looks to be almost a beam of extrasolar planets leading off to the right. That's where the Kepler spacecraft was surveying exoplanets for 4 years and just kept counting what it could see. And that's why the most of the exoplanets we know of are seen in that direction. But there are an awful lot more. Are any of these other worlds like Earth itself? We don't know, but probably most of them are not. Because you have to fulfill a certain set of conditions for a planet to be able to support life like Earth. You need to have the right kind of planet. You've got to have the right kind of mass, the right composition. It's got to orbit the right kind of star. You can't be orbiting a star that gives off too much dangerous radiation. And you also have to be just the right distance from your star. You can't be too close and too hot, or too far away and too cold. So there are a lot of different conditions that a planet needs to require before it can be said to be habitable, or able to support life. And so far as we know, there's only one place that does that. As we approach a medium sized yellow dwarf star and one of its planets, we see that world coming into our view. That world being our own planet, the Earth, which is a very, very unique place, a very special one, which so far is the only place that does have all the conditions needed to support life. That makes our planet the only place where we do find life, a very special, unique, precious thing in the universe, and a place which makes us realize that in all the cosmos, there is no place like home. And with the view of Earth filling our screens, welcome back home to the planet Earth. We hope you've enjoyed our tour of the universe. We wish a happy Thanksgiving to our American audience and to our viewers in other parts of the world. We are indeed thankful for you and your support, and we wish you and your families and your loved ones well. We hope you join us online every Wednesday at this time for our live tour of the universe.